Welcome to Study Loop.
In this case, we want to check the radiation of humans because all of us have some carbon-14 in our body and it will undergo beta-minus emission. So part A wants us to write out the decay scale of carbon-14 to show the end product. So we start with 14 carbon proton. For beta decay, it will produce the electron. And then we will have 47. And then the question says a neutrino is also produced. So we will also add a neutrino. Then part wants us to find the amount of kinetic energy released, knowing the mass of the carbon-14. So we can find the amount of energy if we find the change of mass. Delta M equals the mass of carbon-14 minus the mass of electron minus the mass of which is nitrogen. The mass of carbon-14 is given, and the mass of nitrogen and the mass of electron can both be found from the atom. So the change so 14 is actually 13.999950. U electron is 0.000549 U. Nitrogen is 13.999234 U. Okay. And then together this will give us 1.67 times 10 to the negative 4 U. And this amount has an equivalent Q 0.156 MeV. This is the amount is released. Part C wants to find how many grams of carbon are there in a 75 kilogram person. Well, in order to find that, we need to first find the amount of carbon. So we know that around 18% of each person is made of carbon. So we can 0.18 times 75 to find 13.5 kilogram. So in example 43.9, but each 1 gram will have an activity of 0.255 peak. So now we have 13.5 kilogram. We will have 13.5 times 10 to the third gram times 0.255 BQ per gram. And this is giving us 3.4 times 10 to the third decays per second. And part D asks us the amount of energy that is released. So, well, each end we have 3.4 times 10 to the third decays per second, and each decay emits 0.156 MeV. So we will have 530 MeV per second. In terms of power, it's 8.5 times 10 to the negative 11 joules per second. So last question is what is the amount of energy absorbed, and it wants us what is the amount of energy that one person absorbs from himself. So we can find this by we know this is amount of energy per second. So here we will have this amount of energy times 3.156 seconds in a year. It's going to give us 2.7 times 10 to the negative 3 joule. This is the amount of energy in a year. And then we also want to calculate the dose, so that is per unit mass. So we also need to divide this by 75 kilogram by the mass of a person. This is going to give us 3.6 times 10 to the negative 5 joule per kilogram. And then this is equivalent to using the usual units for the activity. This is 36 micro GY. Also equal to 3.6 mRAD, because R for X-ray is 1, so the equivalent dose is also 3.6 mREM. This is equal to 36 mu SD. All of these equivalent because RBE is 1 for human.